Hey everybody. Today on this one, we're going to be talking a little bit more about functions. We're going to be talking about the different views of a function. Okay, so what that means is there's all these functions, right? We've talked about what those mean, but there's a lot of different ways of displaying kind of what that is. We can display it as a group of points, like in a table. We can show it on a graph as points. And then we talked about last time these function rules is just another name of an equation. So let's just go over a couple of these. Okay, so for this first one, I have a function rule given to me here, and it says f of x. Again, an f of x, if you don't remember, f of x is just a fancy way of, it's just y. It's called function notation. Just think of it as a y. It basically means the same thing. Y equals 2x plus 1. And so the directions say, given the function rule, make a table of values and graph the function. Okay, so I'm given the function rule, and it wants me to make a table from that and then graph it. Table of values first. Okay, so again, what we're going to do is we're just going to pick a set of x values to plug in, -2, -1, 0, 1, and 2. And I'm just going to substitute those in for where the x is in the function rule or the equation. And so the math I'm going to do for each of these is 2 times whatever the x number is plus 1. Okay, so just showing the math for the first one. 2 times the x number here is -2, so 2 times -2 plus 1. Okay, so 2 times -2 is -4. -4 plus 1 is -3. And I'll just go quickly. I did these in the last video, so I'm not going to spend a ton of time re-explaining these here. So if I substitute in -1, 2 times -1 is -2, plus 1 is -1. Sub in 0, 0 times 2 is 0, 0 plus 1 is 1. Sub in 1, and I would end up getting 3. Sub in 2, and then I would end up getting 5. And so those are all the points, so that's filling in my table of values. And then if I graphed that, again, when I have a table, these are just different ordered pairs that I would graph, right? So for this first one, I could rewrite that as -2, comma, -3. So I could graph that point on the graph here. So that would be -2, -3, -2, -3, -1, -1, 0, 1, 1, 3, 2, 5. And again, the check is the points should form a straight line when you graph it, okay? And they're supposed to. That's a good thing, okay? Because this is called a linear function. Again, we'll talk more about that in Unit 4, but and any other, if you picked a different x value than one of these 5, you would get another point that would fall on that same line. Okay, so that's the deal. Okay, but anyway, again, so the kind of the point of this is that we see that again, this function rule is a way of displaying that. Another way of displaying that is through a table, and then another way is displaying that through the graph. Okay, so it's 3 ways of displaying the same function. And so that's probably the easiest way if you're given the equation right away, going from that to the table and then the graph. Okay. Now for number 2, if you're given a table of values, which I will make right here, I have these 5 points here. And it says, given the table of values, graph the function and write a function rule to model the situation. Okay, so for this one, I'm given the table first, and it wants me to make the graph and then the function rule from that. Okay, so a little bit trickier here, you're going to see. Okay, if I'm given the table, it's going to be really easy for me to go and make the graph from that, right? It's just like what I did over here for this one. Okay, so -2, +9 would be all the way up here. -1, 5, 0, 1, 1, -3, and then 2, -7. Okay, and again, it forms that straight line like it should. Okay, so that's making the graph or graphing the function. Okay, but then how do I go and write that function rule? And so the function rule, kind of like the first one here, is going to be f of x equals something. Okay, and this is the really tricky part. All right, to be able to do this, you have to be somewhat familiar with the equation y equals mx plus b. Okay, this is an equation. It's called the slope-intercept equation. It has a lot to do with how we graph lines, but we still need to know what these mean, these letters. Okay, it kind of gives us the format or kind of the general template that we're going to use here. Okay, what I want to look for is that pattern. I mentioned that in the last video too. There's a pattern in your table when you have a function rule that's defined by an equation. I look for a pattern in here, right? So, and we can even draw that. So for like the x values, what's the pattern there? That's easy to see, right? The pattern, I would say, is it increases by 1 each time, right? That's fair to say. Each time the x value increases by 1. But then I look over at my y values, okay? And then my y values are 9, 5, 1, -3, -7, okay? That might be harder to tell, but there is a defined pattern there. To go from 9 to 5, that would be a decrease of 4, right? So if I did 9 minus 4, I'd get 5. If I did 5 to 1, I'd minus 4 again, right? 1 to -3, that's another minus 4, and so on. So there's a pattern in your y values or your f of x values as well. They decrease by 4 each time. So what I could say about this is as x increases by 1, y decreases by 4, okay? As x increases by 1, y decreases by 4. So what that tells me is that that's how much it is moving. And this is especially helpful to see on the graph, okay? And we're getting a little bit into how we graph a line here too, but it's going to be needed to write this function rule, okay? Look at your points. Aren't your points evenly spaced out as well? Now I want you to notice something, okay? If I went from this point to this point, and notice I didn't connect them straight up, I kind of drew an L there, okay? And the reason I did that is, look, I went down 4 to get from this first point to the second point. And this is my first point, right, -2, 9. And this is my second point, -1, 5, right? And so if I counted how many spots does it go down and then to the right to get from this point to this point? Well, I would say it goes down 4 and then right 1, right? It's easy to count that. You go down 1, 2, 3, 4 spaces and right 1 space, okay? And that's going to be true, right? We said it's an evenly spaced out pattern here, and that's going to happen between each point. It follows that pattern of going down 4, right 1. And so you can see that that is illustrated both in the table, right? You see the change in the y values is going down by 4 each time, and then on the graph it's going down 4 spaces each time. And then the x values are going up by 1 each time, and you see on the graph that that's shown by the 1 each time. And even more so, right? These are the y values. And the y on the graph, the y-axis is the one that goes up and down, right? And so the y, I would call that the change in y. What's the change in y? Or in math, that's delta y. Delta is just a fancy symbol that means the change in. How does y change? The change in y, the y direction, the up and down direction, the change there is that it's going down by 4, right? If you think about the y-axis too, going down means what? Well, going down means that's where the negatives are. So it is decreasing by 4. That's what the graph is showing. And again, I know that too from my table. So I would say the change in y is a -4. Okay. And again, I'm going to tie this into the equation. That's what we're working for, is getting this function rule. But we need to know all of this to be able to do that. Okay. And then similarly, I have a change in x as well. Okay. Or again, same thing, delta x. Okay. What's my change in x? Well, I can see from the table that my change in x is that it's increasing by 1. Okay. And I also see that on the graph here too, that in the x direction, right, the x-axis is side to side. Between each point, it is moving right 1 space. And then the x direction is going to the right, positive or negative. Well, going to the right, as you go further to the right, you're getting more and more positive, right? So that is an increase of 1 or +1, or we can even write +1. So what that crazy complicated thing is these two numbers are going to be really important to me for this equation, okay? They're not both of these letters, but what I just found was my m value, okay? My m value. M is called your slope, okay? That's called your slope in your equation. But what I like to say is m is where you move, right? And aren't these two numbers kind of showing where we move on the graph? Moving down 4, moving right 1, moving down 4, moving right 1. So it's telling me where I am moving. Okay, that's what the m value does. And so what I'm going to do is, for this m value, I'm going to write this as a fraction. And so just writing it over here, the m value, I would write as the change in y over the change in x. And I know that seems really complicated, but it's just counting the y direction from point to point, how much it's moving, each time, and then that number's on top of a fraction. And then the bottom number is how much it's moving side to side, or it's usually to the right, okay? So my m value here is going to be these two numbers as a fraction. And so that would be for this one, -4 over +1, okay? And so that is my m value in this equation. So if my equation, again, my format is mx plus b, but my m value, I just found that, is -4 over 1. Okay, that m number is usually always a fraction. Okay, we actually want it to be a fraction. So if I compare that equation, what I have there to this, okay, this said 2x plus 1. And so notice the letter x is still in there. I'm not replacing that with a number. So the x is still there, and that's actually multiplied by the m number. So it's -4 over 1 times x, and then plus b, okay, plus b, okay, what does that mean? Well, on the graph, okay, that's actually talking about a specific point. B value, if m stands for move, I like to say b stands for begin, okay, and that's going to make a little bit more sense when we actually graph the lines ourselves in Unit 4, but for now, the official name for it is the y-intercept. Now what that means is the y-intercept. You notice it has the y-axis on the graph is this vertical axis, right? And so a intercept kind of like in football, intercept means, right, you get in the way of the pass from the quarterback, you get in the way and you catch it as the defender and you run it back for a touchdown, pick 6. A y-intercept on the graph is where the line that we're drawing crosses over this y-axis, okay? What I'm wondering is, where does my line touch the y-axis? And I can see that that happens right here at this spot right there. And that's one of the points that I drew from this table, right? The point that is 0, 1. So that is my y-intercept. And for this, let's actually compare that to this one over here too. Notice where this line crosses the y-axis. It crosses right here. It happens to be the same point, 0, 1. So notice in your equation what the b value is here. The b value here, when I say b value, right, y equals mx plus b, so kind of that last number at the end after the x was +1 in this first equation, okay? And where do you think I get that from this? 0, 1, +1. That's the y value of the point where it touches the y-axis. So that +1 is where that comes from, okay? So it's actually going to be the same for this one, right? Because it's the y-intercept here is also 0, 1. So I'm going to have this say -4x plus 1. So that's actually my full equation here, where my full function rule is -4 over 1x plus 1. Okay, now, when we look at this equation, -4x plus 1, how can you check that? How do you know that that's the equation that it's talking about in this graph or even in this table, okay? Well, here's a way you can check your answers, okay, right? Think about how we did the first one. The first one where we got the equation and we plugged in the values to get the y answers. I can do the same thing here for x. So what it's saying is when I substitute in -2 into this, I should get 9 as an answer, right? And when I plug in -1, I should get +5 as an answer, and so on, okay? So let me just show you that, okay? And just doing the math real quick. And then one other thing too, -4 over 1. And remember, a fraction is like division, so -4 divided by 1, wouldn't that just be -4? So when it's over 1, over +1 like that, you can even just not even write it. You could just think it's just -4 times x, because -4 over 1 is the same as just -4. So if I plugged in -2 into this equation, I want to get 9 as an answer, and I'm checking, do I get that? So if I sub in -4 times -2 plus 1, -4 times -2 is +8, +8 plus 1, hey, what do you know? You get 9 as an answer. Nice, okay. And I will tell you, if you plug in all these other values too, you could even pause it and try it yourself. If you sub in all these other values in for x here, if you did -4 times that number plus 1, you should end up with all these same values, okay? Now that takes a lot of practice. That's one of the toughest things we do in Algebra 1 is going from a table or a graph to the equation, okay? And we're going to work on that the rest of this unit and Unit 3, And in Unit 4, we keep going in Unit 4 as well with that. So don't worry if you don't quite get it yet. I'll still do it in some more videos down the road. So don't worry.